Okay, today's lesson talks about factoring. It's 4-3, solving quadratic equations by factoring. And in our previous lesson at the end, we talked about how the x-intercepts of the graph, and once again, oh, maybe it's already there. Yes, yay. Okay, the x-intercepts of your graph, okay, remember, those are the solutions of your graph, and also how you can get the factored form straight from there. So it's going to be important for you to be able to go back and forth between standard form, factored form, recognizing what the factors and the zeros and how they're all related. So to start off with, let's review your factoring techniques that you should already be familiar with. I know you're all really good at it, but let's just review. Maybe I'll teach you something new, but I doubt it. First and foremost, you should always look for the greatest common factor when you are factoring. So when you look at these four terms that I have here, hopefully you can see the greatest common factor is AY. And when I do that, let's see, what do I have left? I have x squared plus bxy minus cx plus d squared y. And then, of course, you look to see if you can do anything with that, and we cannot, so we're going to go on to the next one. I don't like that color. So let's go here. All right, difference of two squareds, a squared minus b squared. That gives us a minus b and a plus b. You need to be familiar with what those are called. Those two things, when the factors are exactly the same, except for the sign of the second one. So A and B are the same, but the signs are different between them. They're called conjugates. Okay, something that might be new to you would be the sum and difference of cubes. So you've got to know your cubes. A cubed plus B cubed. You start off, the first factor is taking the cube root of each. So that's A plus B. Then I use this factor. You square the first term. You change the sign, you multiply them together, and then you square the last term. So if I do that with subtraction, when I take the cube root, that's going to be a minus b, and I square the first term, change the sign, multiply them together, and square the last term. Now, some people refer to these problems as SOAP. So just so that you're not totally unaware of what that means, or it might help you remember. Okay, what SOAP refers to is whatever sign you have here, this sign will be the same as those. That's not enough. Can I use a different one? Let's go here. All right, so this will be the same. This sign will be the opposite, always opposite. Same, opposite, and then the last one is always positive. It looks like AP. So if you go, I don't know how to factor that, I might say SOAP to you. All right, then we have perfect square trinomials. Let's go here. Perfect square trinomials, a squared plus 2ab plus b squared. And what's going to make the difference is that you recognize that it's two perfect squares, and that always becomes a plus or minus b squared. If it's plus over here, it's plus over there. Minus over here, minus over there. General trinomials. Okay, I'm going to talk more about those in a minute, but you can use whatever is your favorite method. There are so many methods out there. I'm going to talk about one. I've obviously been factoring for a very long time, and I learned the guess and check method, but I have since learned one that is kind of a step-by-step process you can use all the time. So I will show that to you when we get to some of those problems. Okay? Next, we have grouping, or the last method you have if you have four or more terms. And this, of course, is when you're looking at the number of terms. You have any number of terms, you start off with the greatest common factor. If you have two terms, it's going to be one of these three things, or it can't be factored. If you have three terms, it's either going to be a PST or a general trinomial, and four or more terms will be grouping. Okay, and in your grouping, if it's easy grouping, you just look at the first two terms and the last two terms, and you find out what they have in common. What do these two things have in common? They have an A, and that leaves me with x plus y. and I hound on bringing down that sign in between them. What do these two have in common? Is B. Again, what's left? Now, if you want to make it easy on yourself, write the exact same factor and then check it. Negative b times x is negative bx. Negative b times y is negative by. If these two things are not the same, you can't go any further. But since they are, they themselves are a common factor. So this becomes x plus y times a minus b. And that is how that thing factors. Okay? Sometimes, because y'all are a more advanced group, you might have 3 and 1 or 1 and 3. So you've got to kind of be on your toes and recognize those different forms. Okay, so they want us to write in a quadratic equation in standard form. Standard form, of course, is ax squared plus bx plus c equals 0. Write a quadratic equation in standard form with 3 over 5 and negative 5 as its roots. So you're working backwards in this process, but you have x equals 3/4 or and, whichever way you want to put it, x equals negative 5. If you set each of those, get rid of this fraction, multiply both sides by 4, and then, come up a little bit, set each one equal to 0. So that's 4x minus 3 equals 0, and x plus 5 equals 0. This right here, those are your factors. So that means I'm going to have 4x minus 3 times x plus 5. If you start off with an equation, y'all, you will end up with an equation. And when you multiply that out, you're going to get 4x squared plus 20 minus 3 is plus 17x minus 15 equals 0. And that is your equation in standard form. Okay, so kind of an interesting way of saying that, but the zero product property, which you should be familiar with, for any real numbers a and b, if a times b equals 0, then we know a equals 0, b equals 0, or both a and b equals 0. That's how we're able to solve so many of these equations. Stop it. Poo. Both equal 0. Okay, so kind of what we just did. You have a problem, you factor the problem, you set each factor equal to 0, and then you solve it. Okay, so let's go do some examples together. You might not need this video, in which case you can stop and go on. But let's just go ahead and start. So the first one says 20x squared minus, 20x squared plus 15x equals 0. First thing we're always supposed to do is look for a GCF. And the GCF here would be 5x, leaving me with 4x plus 3 equals 0. Set each factor equal to 0. 5x equals 0. 4x plus 3 equals 0. Divide by 5. X equals 0. Subtract 3. LOL. Subtract 3 and then divide by 4. So x equals negative 3/4. So I'm going to go ahead and add 0 right there and box it because I like to box my final answer. So that's what we got. Look at the next one. 4y squared plus 16y. GCF, always the first thing you want to look for. We have a GCF of 4y, leaving me with y plus 4. And so 4y equals 0, y plus 4 equals 0. And y'all are good. That means this one gives me 0, and this one gives me negative 4. To the next one. C8 to the 5th plus 18a to the 4th. Okay, remember your GCF, these have been kind of obvious, but when you have higher exponents, it's always 6 goes into both of them and the lower exponent. So that would be 6a to the 4th, leaving me with a plus 3. Again, set each factor equal to 0. And when you divide by 6, you still have a to the 4th equals 0. And the 4th root of 0 is 0. So a equals 0 or negative 3. All right. Perfect squares and difference of squares. Okay. So, real life, they're not going to tell you what kind of problem it is. You got to be able to recognize it. So we'll keep going though. So you've got the pattern. Perfect squares, these are what I call PSTs. So you're looking to see this is a perfect square and that's a perfect square. But be careful. When you factor that, the square root of 4x squared, of course, is 2x. The square root of 9 is 3. And it always takes this sign. It would be that quantity squared. But check yourself. 2x times 3 is 6x. And 6 times 2 is 12. And if that's the case, then you do have a PST. If it's not the case, then it could be factored another way. And trust me, they will be on there. Okay? So, our perfect square trinomials, just to refresh your, that was a squared plus or minus 2ab plus b squared. And that gave us a plus or minus b quantity squared. Okay, and the next one that we have, the difference of two squares looks a squared minus b squared, and that gives us our two conjugates, a minus b times a plus b. So, to solve, this would factor, actually, I would divide both sides, everything by 9. And that would give you 9x squared minus 1 equals 0. And that factors to 3x minus 1, 3x plus 1. And you're setting each one. Oh, hello, I didn't solve that. Are y'all yelling at me yet? I'll come back to that. Sorry. 3x minus 1 equals 0. 3x plus 1 equals 0. And that, of course, gives me x equals plus or minus 1/3. All right, I'm sorry, guys. Let me go back to this one. So this was 2x minus 3 quantity squared. And then when I take the square root of both sides, 2x minus 3 equals 0. 2x equals not 0. 2x equals 3, so x equals 3 over 2. I hope that y'all are thinking, anyway, how many solutions and what the graph is. This graph is tangent. There's only one solution to it. This graph, of course, crosses it in two different places. All right, on to the next one. 6a squared minus 3a. Again, I'm going to get rid of that GCF, and I can divide now. I don't have to write it in front because it's an equation. If I was factoring, then I'd have to leave the 3 in there. So this becomes 2a squared minus a is equal to 0. And I have a common factor of a, leaving me with 2a minus 1. So a equals 0, 2a minus 1 equals 0, 2a equals 1, and so we have 0 or 1/2. I'm not quite sure what they were pulling because that's not a perfect square or difference of two squares, unless they wanted to factor. Yeah, that doesn't happen. Okay, turn the page. So more factoring. Now, these are the, I think I turned it twice. Yeah, my bad. All right, factoring trinomials. So I'm going to talk to you about this method that I use. You can use whatever method you want. What's most important is that you can do it accurately and efficiently. So to start off with, in A, I don't think y'all are going to have trouble with this particular one, but x squared minus 11x plus 30. Okay, this is a equals 1. If a equals 1 is pretty straightforward, you're looking for the factors of 30. But this is a key. I need the factors that add to give me 11. All right, and y'all know that pretty quickly. That's going to be -5 and -6. So I have x equals 5 or 6. Yeah, so the factoring is not difficult. I hope y'all think the factoring is not difficult when a is equal to 1. All All right, on B, again, A is equal to 1. So I'm looking for a difference. So I'm looking for the factors of 21 that subtract to give me 4. X minus 7 and X plus 3. So X equals 7 or negative 3. I know y'all are doing this faster than I can. Bear with me. Okay. Oh, you're right. We were looking for a difference. So you're just going to hear me say that when I talk about factoring. Okay. Next one. So on part C, if you notice, A does not equal 1. And so if A doesn't equal 1, then you need to remember to multiply A times C. And A times C in this case is 15. So I'm looking for the factors of 15 that still, I got a sum, that are going to add to give me 8. Okay? And let's say right off the bat, you know that's 5 and 3. Of course, negative 5 and negative 3. Whatever A in this case is equal to 15. You have to divide both of these by 15. And if they simplify, so this becomes negative 1 over 3, and this becomes negative 1 over 5. Those fractions that you get, when you move that up, some people call this method slide, divide, bottoms up. They slide these two numbers together to get this product, and then they divide and then bottoms up. So what this becomes, my factors are going to be 3x minus 1 and 5x minus 1 equals 0. Set each factor equal to 0, 3x minus 1 and 5x minus 1. And so I get x equals 1/3 or 1/5. Looks like there's a box there. Okay. All right, look at this next one. A little more challenging. A times C. Now, first off, I would not ever try to factor if A is negative. So I'm going to multiply everything by negative 1. That's a multiplication symbol. So that's going to give me 12x squared minus 8x minus 15 equals 0. Okay, A is not 1. A is equal to 12, which is very important. A is equal to 12. So I have to multiply 12 times 15, which I'm sure you all know is 180. And I'm looking for the factors of 180 that subtract to give me 8. Well, hopefully the first thing that came to mind was 10 and 18. So you can divide like I did there. Some people also just take the 12, and write a ratio. That's why it's called the ratio method. 12 to 10, 12 to 18. It still has a common factor of 2, so this would become 6 to 5. And this has a common factor of 6, so it would become 2 to 3. And of course, that is negative 8. So that means this 18 is negative, and that 18 is negative, and that 3 is negative. But there are your factors right there. So that gives me 6x plus 5 and 2x minus 3. Set each one equal to 0. 6x plus 5 equals 0. 2x minus 3 equals 0. X equals negative 5 over 6 or 3 over 2. And there you have it. All right, so we got a word problem. Juan recorded his brother bungee jumping from a height of 1,100 feet. At the time the cord lifted his brother back up, he was 76 feet above the ground. If Juan started recording as soon as his brother fell, how much time elapsed when the cord snapped back? Use this function where c is the height in feet. So, if he started at 11, that's not 11. If he started at 1,100 and the cord bounced back at 76, when I subtract those two, that's the height in feet of the cord, okay? how much time elapsed when the cord snapped back. So our function is going to be f of t equals negative 16t squared plus 1024. Okay, and if I want to know how much time elapsed, that means I'm looking for t. And so I'm going to set that equal to 0 and solve it. (16t squared equals 1024). When you divide both sides by 16, you get t squared equals 64. So t, of course, equals plus or minus 8. We cannot have a negative time. So at what time does it happen? 8 seconds. How much time elapsed when the cord? So for 8 seconds, he was just falling. All right. At the bottom, when you see your homework problems, look at the bottom. I'm giving you more practice in cubes because I wasn't happy with what I saw. So to refresh your memory, these are all going to be cubes on this worksheet. So our cubic pattern, a cubed plus or minus b cubed. Okay, when we factor it, a plus or minus b, because it's the same, then I square the first term, opposite, multiply them together, and then always positive, and square the last term. So I'm going to do 2 examples, a little bit different than the basic ones that we just had. So this first one here, 8t cubed. So you got to recognize what your cubes are. That's a perfect cubed, and that's a perfect cube. The cube root of 8 is 2. Cube root of t cubed is t. Same sign. Cube root of 27 is 3. Cube root of 27 cubed is, w cubed is w. And then from this factor, square the first one, 4t squared. Change the sign, multiply them together, always positive, and square the last term. And I didn't mention it before, but this thing will never ever be factorable. It's always prime. So if you're solving even a more simpler cubic equation, you actually have to use the quadratic formula or complete the square to solve that thing. Okay, last one. We talked about this. When you have 2 terms, the first thing you're always supposed to do is look for a GCF. These 2 have a GCF. Okay, that GCF, of course, is 2x. So I have 2x times x cubed minus 64. And then you can see that these 2 are perfect cubes. So 2x, x minus the cube root of 64 is 4. Square it, change the sign, multiply it together, and square the last one. And that is how that factors. So I'm not going to do any more because I don't want to bore y'all. Have fun factoring. You will use it a lot. And email me or let me know if you have any questions. Thank you so much.